Hello everyone. In this video we are going to discuss exercise 13.3. So let us start with the first question. A metallic sphere of radius 4.2 is melted and recast into the shape of a cylinder of radius 6 cm, and we have to find the height of the cylinder. It means there was a metallic sphere, it was melted, and then the melted iron was recast into the shape of the cylinder. So we have to find the height of the cylinder. Now it means the volume of the metallic sphere and the cylinder would be same. So therefore we will equate the volumes of the sphere and the cylinder, and then from that we will get an equation from where we will be able to find the height of the cylinder. So first of all, let the radius of the metallic sphere be r. Radius of metallic sphere. So this is the radius of the metallic sphere, this be r, and this is given to be equal to 4.2 centimeters. And let capital R be the radius of cylinder. Okay, this is given to be equal to 6 centimeter. We have to find the height of cylinder. So we will equate volume of sphere with volume of cylinder. Now we will put the formula. What is the volume of sphere? Volume of sphere is given by 2/3 pi r cube, and volume of cylinder is given by pi r square h. We have to find h, and we know all other values. So first of all, from here you can cancel the value of pi. Now you are left with, keep h on one side and shift the other terms on the other side. So 2/3 r cube upon r square. So this implies h is equal to 2/3 into, what is small r? Small r is 4.2. So 4.2 into 4.2 into 4.2 upon capital R is 6. 6 into 6. So you can remove the decimal, and in denominator you will get 1000. Now you can cancel the terms. That's all. So now on solving you will get it equal to 2.74 centimeters. So therefore height of the cylinder is 2.74 centimeter, and this is your answer. Now in next question it is given that there are three metallic spheres are there of given radius 6 centimeter, 8 centimeter and 10 centimeter, and three of them are melted, and then a large sphere is made out of them. We have to find the radius of this large sphere. So what you will do, suppose this radius to be r1, this to be r2, and this to be r3, and this radius that you have to find be r. Now what you will do, you will equate their volumes. So because these three are melted to form this, so volume of these three and this large sphere would be equal. So you will say volumes to be equal, that is pi. What is the formula for finding the volume of sphere? It is 4/3 pi r cube. So 4/3 pi r1 cube plus 4/3 pi r2 cube plus 4/3 pi r3 cube will be equal to 4/3 pi r cube. So now you will take 4/3 pi common from left hand side, so it will cancel. So these terms will cancel out, and you will be left with r1 cube plus r2 cube plus r3 cube is equal to capital R cube. Now you have the value of r1, r2 and r3, so you will put it, and from here you can find the value of capital R, and that would be your answer. So I am not solving it, but I have told you the method. Now let us see the next question. A 20-meter deep well with diameter 7 meter is dug, and earth from digging is evenly spread out to form a platform 22 meters by 14 meters. find the height of the platform. It means a well is dug. Usually the shape of well is cylindrical, and moreover here height and radius are diameter is given, so it's confirmed that it would be in the shape of a cylinder only. So well is in the shape of cylinder, so the height of well is given to be 20 meters, and let it be capital H, and this is height of well, and diameter is given to be 7, so radius will be 7 by 2 meters. Now the mud that was taken out while digging the well is spread out evenly in the shape of a platform, and the length and breadth, by means multiplication, so length and breadth are given. We have to find the height of the platform. It means the platform is in the shape of a cuboid, like this it would be. So we have to find the height of the cuboid given its length and breadth to us. We have to find this height. So the mud taken out is only transformed into the shape of platform, therefore the volume will be same. So we will equate the volume of the cylindrical well to the volume of the cuboid or the volume of the platform. So write volume of well is equal to volume of platform, or you can say volume of cylinder is equal to volume of cuboid in this case. Now put the formulas. Volume of cylinder is pi r square h. Capital R and capital H are the height and radius of the cylinder we have supposed, is equal to volume of cuboid is LBH, length into breadth into height. Now put the values 22 by 7 into 7 by 2 into 7 by 2 into capital H is 20 is equal to, length is given to be 22, breadth 14, and height we have to find out. So now keep H on one side and shift other terms on the other side. So you will get 22 by 7 into 7 by 2 into 7 by 2 into 20 upon 22 into 14, because 22 into 14 will come in denominator. Now you cancel the terms. That's all. So H is equal to 10 by 4, that is equal to 5 by 2. So this is equal to 2.5 meters. So 2.5 meter is the height of the platform, and this is your answer. Now see the next question. A well 3 meter in diameter is dug 14 meter deep. The earth taken out of it has been spread all around it in the shape of a circular ring of width 4 meter to form an embankment. Find the height of the embankment. So what they mean is a well was dug. So a well is in the shape of a cylinder. Now they are saying that the well has a diameter of 3 meters and height of 14 meter. The earth that is taken out has been spread around it in the shape of a circular ring. So it is spread around in this way. Okay, so suppose this is the ground level and the well is dug deep, and this area has been made, this is called embankment. This area has been made with the mud that was taken out. So this area I am making it here. So this area would be also in the shape of cylinder only. Okay, like this. So this area is also of the shape of cylinder, this area, where the radius of the inner cylinder, this will be the inner cylinder. So the radius of the inner cylinder, this would be well only. Okay, so the radius of the inner cylinder would be equal to the radius of the well. The radius of the well is 3 by 2 meters, and the radius of the outer cylinder would be equal to 3 by 2 meters plus this width, and this width is given to be 4 meters. So 3 by 2 plus 4 meters. Okay, so what we will do in order to find the height, we have to find this height of the embankment. Let it be h. So in order to find this height, we will equate the volume of this embankment to the volume of the well. Now how you will find the volume of embankment? In order to find this volume, you will find volume of the outer cylinder minus volume of the inner cylinder, that is the volume of well, and in that way you will find out the volume of this embankment. So first of all, you will find inner radius is equal to radius of well, and that is equal to 3 by 2 meters, and outer radius is equal to radius of well, that is 3 by 2 plus width, that is given to be 4. So it is equal to 11 by 2 meters. Now you have both the radius. Now we will equate. So what you will do, you will write volume of well is equal to volume of embankment, or you can write it as volume of earth taken out in order to make the well is equal to volume of earth used to make the embankment. It's one and the same thing. So now you put the formula. Volume of well will be given by pi r square h. Now suppose height of well be capital H and radius is capital R, or let the radius be small r only. So you have pi r square h. This is equal to volume of embankment. Here you mention inner radius is small r and outer radius is capital R. So it would be easy for you. Volume of embankment is volume of outer cylinder, that is pi r square h minus volume of inner cylinder, that is pi r square h. Okay, height will be same, just difference would be in radius. So this is our equation. Now see what you can take out common. Pi r square h is equal to pi r square, pi h can be taken out common, so r square minus r square. So here pi and pi will cancel. Now put the values. Here this r is the inner radius or the radius of well, that is 3 by 2. So 3 by 2 into 3 by 2 into height of well. So height of well is 14 meters. So into 14 is equal to h. This h we have to find out, height of the embankment. Here capital R is outer radius, that is equal to 11 by 2 meters. So 11 by 2 square minus small r is 3 by 2. So 3 by 2 square. So now you will get 3 into 3 is 9. So 9 into 7 upon 2 is equal to h, and on solving you will get 121 upon 4 minus 9 upon 4. So now you can take the LCM. So you will get 63 upon 2 is equal to h. Here on taking the LCM, 121 minus 9 would be equal to 112 upon 4. So from here you will get h is equal to 63 by 2 into 4 upon 112. Now cancel the terms whatever possible. So here you will get 2 5s are 10, 6. So 63 upon 56. So these are of the table of 7. So 7 9s are and 7 8s are. So 9 upon 8, and this would be equal to 1.125 1.125 meters will be the height of the embankment, and this is your answer. So in this way you will solve this question. Now let us move on to the next question. A container shaped like a right circular cylinder having a diameter of 12 centimeters and height of 15 centimeters is full of ice cream. The ice cream is to be filled into cones of height 12 centimeter and diameter 6 centimeter having hemispherical shape on the top. So the container is of the shape of cylinder. So this is the shape of the container, and the height of the container is given to be 15 centimeter and diameter is given to be 12 centimeter, and the cones are of this shape, cones having a hemispherical top. So the height of the cone is 12 centimeter, the diameter of the cone and the hemisphere are 6 centimeter. So we have to find that how many cones can be filled with ice cream. So what you will do, you will say the volume of the cylinder is equal to, if you will suppose that there are n cones, so suppose that let n be the number of cones. So you will say volume of the cylinder is, or the volume of the container is equal to n into volume of one cone. Okay, because the same ice cream would be transferred in the cones, so the volume of the ice cream will remain same. Therefore we are saying volume of container is equal to n into volume of one cone. So volume of container means volume of cylinder. Cylinder is having a height of 15 centimeter. So let height of the cylinder be capital H, height of cylinder, and let height of cone be small h, height of cone. Radius of cylinder be capital H, and radius of cone be small r, capital R, sorry, small r. Okay, so now you put the formula. Volume of container is pi r square h. R square h is equal to n into volume of cone. Now volume of cone will be, the cone is actually the cone of ice cream we are saying. So the volume will be volume of conical part plus volume of hemispherical part. You write here volume of conical part plus volume of hemispherical part. So now you put the formula, you will get pi r square h is equal to n into volume of conical part. What is the volume of cone? It is 1 by 3 pi r square h plus volume of hemisphere is 2 by 3 pi r cube. Here small r means radius of cone, that is equal to radius of hemisphere. So we will use same r. So now pi r square h is equal to n, you can take pi r square also common, so pi r square common. Now in the bracket you are left with 1 by 3 h plus 2 by 3 r. Now you put the values of r, h, and here you can cancel pi. So r, capital R is the radius of cylinder, that is 6 centimeter. So 6 into 6 into height is 15 is equal to small r is radius of cone or radius of hemisphere, it is 3. So 3 into 3. So here 1 by 3 into height of cone is 12 plus 2 by 3 into radius is 3. So now cancel the terms whichever possible you will, and here n is also there. So now keep n on one side and shift other terms. So you will get, keep n here only, you will get 6 into 6 into 15 upon 3 into 3, okay, into, wait, you can't shift just like that. First of all, you need to add also. So on adding 4 plus 2, you will get 6. So into 6. Am I clear? Now, what you will get is, you cancel the terms first of all. So you will get n is equal to 10. So therefore, 10 cones can be filled with the container. So this is the answer. Now let us see the next question. Now there's another question in which they are saying that how many silver coins 1.75 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid of dimensions 5.5 centimeter into 10 centimeter into 3.5 centimeter. So it is also similar. So I am not solving. I am just telling you that the coins should be taken as cylinder, because coins are actually of the shape of cylinder like this. They are having a height, that is the thickness that is given to be 2 millimeter, and the diameter is given to be 1.75 centimeter. So here you have to remember that you have to convert millimeter into centimeter. You have to make the units same, otherwise your answer will not come. It would be wrong. So just keep in mind to make the unit same and take coin as a figure of cylinder, and then you equate n into volume of one coin is equal to volume of the cuboid. Now let us see the next question. A cylindrical bucket 32 centimeter high with radius 18 centimeter. Cylindrical bucket with a height of, here you don't need to draw the figures, I am just drawing for your clarity. So the bucket is of the height of 32 centimeter and radius 18 centimeter, and it is filled with sand, and from that sand only the bucket is emptied, and from that sand a conical heap is made, and the height of the conical heap is 24 centimeters, and we have to find the radius of this conical heap and the slant height. So we need to find R and L. So this is also very simple. Suppose this is capital H, height of the cylinder, and capital R, radius of the cylinder. So you will equate volume, because the sand is same, so the volume of sand will remain same. So we will say volume of cylindrical bucket is equal to volume of conical heap. So what is the volume of cylinder? It is pi r square h, and volume of cone is 1 by 3 pi r square h. So from this equation you have the value of small h, you have the value, pi will be cancelled, you have capital R and capital H. So you can find the value of R from here. So you will get radius, and in order to find the slant height, you know that if you will see this is a right angle triangle, and slant height is equal to height of cone square plus radius of cones square. So L square is equal to h square plus r square. So from here L is equal to root h square plus r square. So from you will have the value of h also, and you will find the value of r, and you will put it here. So you will get the value of slant height as well. So in this way you have to solve this question. Now see the next one. Water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 kilometers per hour. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is required? So it is given that the water is from a canal which would be in this shape of a cuboid only. Okay, the width is given to be 6 meter, and it is given that it is 1.5 meter deep. So this height is given to be 1.5 meter, and the water is flowing with a speed of 10 kilometer per hour. Now what is the meaning of 10 kilometer per hour? That the water covers a distance, but distance covered would be the length, actually length of the canal. So the water covers a distance of 10 kilometer in 1 hour. So can we find out the volume of water or in the canal in 1 hour? Yes. So volume of water in the canal in 1 hour is equal to length into breadth into height is the formula for finding the volume of cuboid. Canal is in the shape of cuboid. So length into breadth into height. Here length will be 10 kilometer. Now everything else is in meter, so we will convert 10 kilometer also in meter. So it is length is given to be 10 into 1000 because we are converting it in meters, into breadth is 6, into height is 1.5. okay, so you will solve this, you will get it equal to 90,000 meter cube. So this will be the volume of the canal. Now they are asking that how much area will it irrigate in 30 minutes if 8 centimeter of standing water is required. 8 centimeter of standing water, it means if this is the place that they want to irrigate, so this will also be in the shape of the cuboid only, and the height would be equal to 8 centimeter because 8 centimeter of standing water is required. So this height would be 8 centimeter, that is equal to 8 upon 100 meters. We are converting everything into meters because we have to make the units same. Now we have to find how much area. So area is length into breadth, so it means we have to find L into B. Now you say, if volume of water in a canal in 1 hour is 90,000 meter cube, then how much volume of water will be there in 30 minutes? We have to find out volume of water in 30 minutes so that we can find out the area that is irrigated in 30 minutes. So volume of water in 30 minutes is equal to, in 1 hour means 60 minutes. So in 1 hour it is 90,000. So in 30 minutes it would be upon 60 into 30. We will do unitary method. So you will get it equal to 45,000 meter cube. So 45,000 meter cube is the volume of water that would be here in the field in 30 minutes. So now what is the volume of the field? Volume of the field is length into breadth into height. Length into breadth into height because it is of the shape of the cuboid only. Now here length into breadth is equal to area of rectangle. So we have to find this area, and H is given to be 8 centimeter, that is equal to 8 upon 100 meters is equal to this volume. So this is equal to 45,000. Now from here you will get the value of A, that is area irrigated in 30 minutes will be equal to, so A is equal to 45000 into 100 upon 8, and that is equal to 5,62,500 meter square. So this is the area that is irrigated in 30 minutes, and this is your answer. Now let us see the last question of this exercise. So this question is also similar to the previous one. Here a farmer connects a pipe of internal diameter 20 centimeter and from a canal into a cylindrical tank in his field which is 10 meter in diameter and 2 meter deep. So the diameter of the pipe is given, it means the pipe is cylindrical. So this is the pipe having a diameter of 20 centimeters. It is connected to a cylindrical tank which is having, so the cylindrical tank is having a diameter of 10 meters and it is 2 meter deep. So if water flows through the pipe at the rate of 3 km per hour, they are saying that the water flows at a rate of 3 km per hour. They are not directly giving us the height of the pipe or the length of the pipe. They are saying that the water flows at a rate of 3 km per hour. So 3 km per hour means it covers a distance of 3 km in 1 hour. That means the height or the length of the pipe is 3 km for in 1 hour. Okay, you can say that. So how much time will it take for the tank to be filled completely? So what you will do, first of all, you will find out the volume of tank. Volume of tank is equal to pi r square h, where pi r is 10 by 2 into 10 by 2 into height is 2. So from here you will get it equal to 22 by 7 into 100 upon 2. You can cancel or you can leave it like that only, means 100 by 2 pi or 50 pi it would be. So you can do in any way. Let me write it equal to 50 pi only. So 50 pi will be the volume of tank, 50 pi meter cube. Now volume of water that is flowing through the pipe in 1 hour, it would be equal to it is in the shape of cylinder only, so we will apply the formula for cylindrical figure, that is pi r square h. Now keep pi as it is. Radius is 20 by 2. Now it is in centimeters, so you will convert it in meters. So it is 20 by 2, that is 10. So in order to convert it into meter, you will divide it by 100. So into 100. So into I am writing 20 by 2 as 10 only now because it is r square, so we have to specify it 2 times, into 100 into height would be 3 kilometer. Okay, because in 1 hour the distance covered or the length of the pipe or the height of the pipe is 3 kilometer. Now you will convert 3 kilometer in meter also. So 3 into 1000. So now you will solve this. You will get, so it is equal to 30 pi meter cube. Okay, now what you will do, you have to find the time that would be taken in order to fill the tank. So you say that the time taken to fill 30 pi meter cube in tank. So 30 pi meter cube water is filled in the tank in 1 hour. To fill 1 meter cube of water in tank, it would be equal to 1 upon 30 pi r. And so time taken to fill 50 pi meter cube, because the volume of the tank is 50 pi. So time taken to fill 50 pi meter cube of water in the tank is equal to 1 by 30 pi into 50 pi hours. Okay, now you will cancel pi and 0 will cancel. You will get 5 by 3 hours, or you can convert it into minutes. In order to convert it into minutes, you will multiply 1 hour is equal to 60 minutes. So you will multiply 5 by 3 with 60. So 5 by 3 into 60 minutes, that is equal to 100 minutes. So 100 minutes is your answer. So 100 minutes are taken in order to fill the tank completely. So with this we have covered exercise 13.3. In the next video we will continue with exercise 13.4.